You're reading a text message, just words on a screen, but something shifts in your chest before you even finish the sentence. Your body knows before you do. That feeling, that visceral reaction to nothing but symbols on glass, isn't poetic, it's chemical. And now, for the first time, scientists have measured it. This is the psychology of people. I'm exploring the brain research that's changing how we understand language itself. In January 2025, a team at Virginia Tech published something unprecedented. They measured dopamine, serotonin, and norepinephrine releasing inside living human brains while people processed emotional words. Professor Read Montague put it bluntly. They were the first to simultaneously measure all three neurotransmitters in humans while tracking how people interpret and respond to language. What they found challenges everything we thought we knew about how the brain processes meaning. The words you're hearing right now, they're changing your brain chemistry in real time. Let me back up. Dopamine, serotonin, norepinephrine. You've probably heard these names. Pop science has assigned them simple roles. Dopamine equals pleasure. Serotonin equals happiness. But that's the bumper sticker version. These chemicals are ancient. They evolved over hundreds of millions of years, not to make you feel good, but to keep you alive. Norepinephrine spikes when there's danger. Dopamine signals whether something's worth pursuing. Serotonin modulates mood and social behavior. Survival systems, all of them. But here's the thing about language. It's evolutionarily recent. Really recent. Anatomically modern humans have been around for about 300,000 years. Complex language? Maybe 100,000. So the question becomes, how do these ancient survival systems, designed to detect threats and rewards in the physical world, get recruited to process something as abstract as words? That's what this research set out to explore, and they had an opportunity most neuroscientists never get. The study involved patients who were already undergoing brain surgery, either deep brain stimulation for essential tremor or electrode placement to monitor seizures. Researchers had direct access to living brain tissue. Think about what that means. Most brain chemistry research uses indirect measures, blood tests, brain scans that show activity but not actual chemical release. This was different. The researchers used electrodes to measure dopamine, serotonin, and norepinephrine actually releasing in real time. Not proxies. Not estimates. The chemicals themselves fluctuating moment to moment. While the electrodes measured chemistry, the patients viewed words on a screen. Simple words. Some positive, like love or joy. Some negative, like grief or fear. And some neutral, like table or chair. And here's what the data showed. Emotional words, both positive and negative, triggered measurable changes in all three neurotransmitter systems. The brain responded chemically to abstract symbols. But it wasn't simple. Different words triggered different patterns. Positive words, negative words, neutral words, each created distinct neurochemical signatures. It's not one chemical equals one emotion. Professor William Madhow, one of the lead researchers, described it this way. The emotional content of words is shared across multiple transmitter systems, but each system fluctuates differently. What does that mean practically? It means emotions aren't simple switches. When you read the word betrayal, you're not just triggering negative emotion chemical. You're creating a symphony of neurochemical changes. And then came the surprise. The thalamus lit up. The thalamus, a region that, according to neuroscience textbooks, has nothing to do with language processing. Madhow called it a surprising result. A region that hasn't been thought to have a role in processing language or emotional content. Yet it showed neurotransmitter changes in response to emotional words. The thalamus is sometimes called the brain's relay station. It routes sensory information to different regions. But language processing? That was supposed to happen elsewhere, in Broca's area, Wernicke's area. This finding suggests the thalamus might be involved in tagging incoming language with emotional significance, routing words through chemical gates before they reach higher processing areas. The study also revealed hemispheric differences. Dopamine release in the anterior cingulate cortex, a region involved in emotion regulation, showed different patterns depending on which side of the brain they measured. This hemispheric dependence adds another layer of complexity. The left and right sides of your brain aren't just processing language in parallel, they're responding to emotional content differently at the chemical level. So, what does this mean for our understanding of language? For starters, it means words aren't just information, they're triggers. Biological triggers with measurable neurochemical consequences. When someone tells you it's just words, they're technically wrong. At the level of brain chemistry, words activate the same systems that respond to food, danger, and social bonding. This study was published in Cell Reports in January 2025. That's a prestigious peer-reviewed journal. The methodology was rigorous. The findings are being taken seriously. But, and this is important, the study used a specific population. Patients undergoing brain surgery aren't necessarily representative of everyone. That's a limitation the researchers acknowledged. Still, this research opens doors that weren't previously visible. If emotional words trigger neurochemical cascades, what are the implications for, well, everything involving language? Think about advertising, political speeches, the news you consume. Social media feeds carefully optimized for engagement. Every word is potentially a neurochemical event. This isn't about fear-mongering, it's about awareness. Understanding that language has physiological effects changes how you might choose to engage with it. The researchers measured distinct response patterns. Positive words, negative words, neutral words. Each created unique signatures, not just different intensities, but qualitatively different chemical responses. Region-specific responses to the anterior cingulate cortex responded differently than the thalamus. Different brain regions, different chemical responses to the same word. Here's where it gets personal. Every conversation you have, every headline you read, every podcast you listen to, including this one, is creating chemical events in your brain. That slight shift you felt when I said fear earlier, that wasn't imagination. If the researchers had electrodes in your thalamus right now, they could measure it. The study examined what scientists call valenced words that carry emotional charge. Valence refers to the positive or negative quality of the emotional content. What's remarkable is that all three neurotransmitter systems responded. It wasn't just dopamine for positive words or norepinephrine for negative ones. All three chemicals changed in different ways for all emotional content. This challenges the simplified models we've been handed. You know the ones. Dopamine is the reward chemical, serotonin is the happiness chemical. Real brain chemistry is messier, more interconnected. And the research continues. This study provides a foundation, but it also opens questions. How do these patterns differ across individuals? What about people with mood disorders? What about different languages? Do emotional words in French trigger the same patterns as emotional words in Mandarin? The methodology now exists to ask these questions. So what can you do with this information? Here's a place to start. You might want to consider becoming more aware of your linguistic environment. Not paranoid, just aware. The words you encounter daily, in news, in social media, in conversations, may be modulating your neurochemistry in ways you weren't consciously tracking. It's worth noticing. Some people find it helpful to take inventory. What emotional valence dominates your information diet? If it skews heavily negative, that's potentially worth examining. Consider this. Research suggests that intentionally exposing yourself to positively valenced language might have cumulative effects on neurochemistry. Reading poetry, for example, listening to uplifting conversations. And consider the words you use with others. If your language triggers their neurotransmitter release, and this research suggests it does, then how you speak becomes a form of neurochemical influence. This isn't about policing every word. That would be exhausting. It's about recognizing that language isn't neutral, it's biologically active, and that knowledge might change how you engage with it. Notice how your body responds to certain words, that subtle shift. It's not imagination. You're experiencing something the researchers could measure with electrodes. Trust that sensation. If this kind of psychology research interests you, hit subscribe. We cover stories like this every week, the research that changes how we understand why people do what they do. The Virginia Tech study represents a methodological breakthrough. Direct neurochemical measurement during cognitive tasks had been done before, but not with all three monoamine neurotransmitters simultaneously. This matters because these chemicals interact. Dopamine influences how serotonin is released. Norepinephrine modulates both. You can't understand the full picture by measuring just one. And that brings us back to language itself. Words aren't processed in isolation in the brain. They're integrated with memory, emotion, sensory associations, bodily states. Everything connects. When you read the word ocean, something happens. Maybe a memory surfaces. Maybe a slight feeling of relaxation or unease, depending on your history with water. That's not metaphorical. It's chemical. The Cell Reports paper used sophisticated statistical analysis to isolate which patterns were reliably associated with each word category. This wasn't simple correlation. It was rigorous causal analysis. What strikes me about this research is how it bridges two things that seem separate: ancient survival chemistry, modern symbolic communication. Turns out they're using the same hardware. Language piggybacked on existing systems. Evolution is economical that way. Why build new circuits when you can repurpose old ones? That's why words feel the way they do. They're not just symbols being processed by some neutral language module. They're running through systems that evolved to respond to real threats and real rewards. The researchers noted that their findings might have implications for understanding language-based therapies. Cognitive behavioral therapy, for example, uses language to change patterns of thought and emotion. If we now know that words trigger neurochemical release, that provides a mechanism for why talking therapies work. They're not just changing thoughts, they're literally changing brain chemistry through language. There's something profound in that. The words a therapist chooses aren't just communicating information, they're selecting which neurochemical cascades to trigger in the client's brain. So here's a thought experiment. Consider tracking, even roughly, how different words make you feel over the next few days. Not analytically, just noticing. Building awareness. Which headlines create tension in your shoulders? Which conversations leave you feeling elevated? Which words consistently produce a subtle negative response? That data is valuable. Once you notice patterns, you may find yourself naturally adjusting, spending less time with certain sources, seeking out others. Your body is giving you neurochemical feedback. This research just confirms it's real. This brings me to something I've been thinking about. The research measured involuntary responses. The patients weren't trying to feel anything. The chemicals released on their own. That suggests something important. You can't consciously control these neurochemical responses to words. They happen before you decide how to feel. But you can control your exposure. So, words. They're not neutral carriers of information, they're biological events, triggers for ancient chemical systems that your ancestors needed to survive. The researchers at Virginia Tech gave us something new. They may be invisible visible. They measured what we've always felt but couldn't prove. Words change us, literally. I'll leave you with that. The language you surround yourself with isn't background noise, it's medicine or poison. Choose accordingly. This has been The Psychology of People. Until next time, pay attention to the words you let in.